Hello everyone, welcome to the Consciousness Physics lecture series. This is lecture 4 of Mathematical Physics, and in this lecture we are going to look at vector products. So for understanding vectors, you have to imagine that you are in the middle of an ocean, and in the deep blue sea there is a ship in the middle of the ocean, and it has a mast, and it is run by the wind and the mast. So wind will force the ship to move in one direction, and the mast will steer the ship. So you can assume those wind in different directions as two vectors, right? So vector A in the one direction and vector B in another direction, two wind directions. You can superimpose the vector B on the vector A's axis, and you can find that using the parallelogram rule of vector addition, you can add vector A and vector B, and you get A plus B must be equal to C. So that is the resultant direction of the two vectors, and this will steer the ship in one direction, right? So vector C is the direction to steer the ship, and this is known as law of vector addition. So the vector will give you the direction of vector C will give you the direction of the ship. Now we have to imagine something different called vector products or multiplication of vectors. So first of all, what you need to do is you have to consider a person hitting a ball in a golf court, right? A golf ball with a golf club hitting the ball. So you have you're imparting the force of the bat on the ball. So there is two vectors, the vector of bat and the vector of the ball, right? The vector force is imparted on the ball. So vector A determines the vector of the bat and vector B determines the vector of the ball. So you can separately consider these two vectors, how it interacts, and you can see that you can resolve this vector into xy plane. You get ax and ay for A and bx and by for B. So you have resolved this component into xy plane. Now you can see how the components actually interact, right? So you can resolve those vector A into vector B by combining them together, and you can see that vector A will have an x component ax, right, in the b's direction, and this will impart onto board. So ax is equal to a cos theta using the trigonometric rule itself. So total force on the board will be the x component of the bat, so which is a cos theta. So total force will be a cos theta times the existing force, which is b. So a b cos theta will be the total force on the board, which is known as the dot product. So that is the total imparting force on an object is called the dot product. So dot product will give you the actual magnitude of force in one direction on either vectors from one another. Okay, so that's dot product. Now let's understand what is cross product. So you have to consider two vectors interacting in a field of area, right? This is the area between the two vectors, and this is the interacting area, and this area could be a vector. So this area is known as the interacting field, and this is the cross product. So how can you calculate the cross product or interacting area? So you have to consider this vector interaction as a parallelogram. So you can draw the parallelogram, and you can say that this is the vector parallelogram, and you have the base and this slightly angled A, right? So you have to find out the x component and y component to find the area. So x is just the B, and y has to be found out. So you can take the triangle, and there is theta angle. So sine theta must be equal to y by A. So y is A sine theta. So that's the y component. So the total area will be b times a sine theta or ab sine theta. So this is known as the cross product of a vector, right? So this is the cross product, which is magnitude of a times magnitude of b times sine of the angle. So that is a cross b right there. A cross b must be equal to ab sine theta, and then we have a dot b, which is known as ab cos theta. So those are the two operations, vector multiplication operations that we use. So the dot product will give you the magnitude of force. The cross product will give you the area of interaction. Area is a vector. So you can use the right-handed coordinate rule to identify the direction of this vector. So you can use the thumb and fingers, and we have two directions, to the up and to the bottom. So B cross A will be to the up, and A cross B will be to the bottom direction. So that will be the vector representations right there. Now what we can do is that we can see what our Cartesian coordinate system interacts with this kind of vector product. So there is x and y and z. So how can you find out x dot y? So x dot y is just magnitude of x times magnitude of y times the cos of the angle, right? So we have the x, y and z axis, and the angle between it is 90 degrees. So basically it is xy cos 90, right? Cos 90 is equal to 0, so it is 0. So similarly, y dot x must be equal to z dot x, which is equal to x dot y, which is equal to 0, right? Just like that, similar. So in polar coordinate system, we have the spherical polar coordinate system where we have r, theta and phi, right? So r, theta and phi, r is in this direction and theta is from the z axis. So from the top to bottom, it is perpendicular to r cap, and we have the phi cap, which is from the x axis, right? So that's the direction of the three vectors. So similarly, we can find out r dot theta cap. So r dot theta cap must be equal to r dot phi cap must be equal to r dot theta dot phi cap, that must be equal to 0 in polar coordinates. So now let's look at what we have in cylindrical coordinates. So in cylindrical coordinates, we have r, phi and z cap, which are all perpendicular to each other. So r dot phi cap must be equal to r dot z cap must be equal to theta dot z cap must be equal to 0 similarly. And now we can look at what is r dot r cap. So same vector dotted into itself. So they are in the same direction. So angle between them is 0. So r dot r cos theta or cos 0, that is equal to 1. So r dot r is equal to phi dot phi must be equal to theta dot theta, that must be equal to x dot x, that must be equal to y dot y, that must be equal to z dot z, which are all in the same direction. So it is equal to 1. So that's the unit vectors. So let's look at what is x cross x. So xx sine theta, theta is 0, so sine 0 is 0. So x cross x must be equal to y cross y must be equal to z cross z must be equal to theta dot theta, theta cross theta, and that must be equal to r cross r must be equal to phi cross phi, that must be equal to 0, right? So that's basic. Now let's look at what is x cross y, right? So we have to look at the x, y and z plane right now, and you can see that x, y and z are 90 degrees. So we can use the right-handed axis rule, right-handed rule, and we can find the, using thumb direction, we can find the direction of the area. And now you can see the positive direction, which is a positive up direction. The area is in the positive up direction. So x cross y is xy sine 90, that is equal to 1, positive 1. And y cross x is equal to negative 1, because it will be on the bottom axis. So r cross theta must be equal to theta cross phi, that must be equal to x cross y, that must be equal to y cross z, that must be equal to positive 1, whereas theta cross r must be equal to phi cross theta, that must be equal to y cross x, that must be equal to z cross y, must be equal to -1, right? So we can use a simple rule to understand all this. So we can draw a circle, and we can write down in Cartesian coordinate system x, y and z, we have a anti-clockwise direction which is positive, whereas the clockwise direction is negative for cross product. Similarly, in spherical, you have r, theta and phi. In the anti-clockwise direction, it is positive, whereas in the clockwise direction it is negative. Similarly, cylindrical as well, r, phi and z. In the anti-clockwise it is positive, in the clockwise it is negative. So thank you so much for watching this video. Please like, share and subscribe the video for more, and please comment down below for any kind of information or feedback that you can give me.